Make Code and the BBC Microbit. I'm your instructor, Dave Semelink from GoDigitalSA Foundation. And today we're looking at Unit 8, Booleans. Lesson A is Understanding Booleans. What we'll learn about Booleans and Boolean operators. So what is a Boolean? Okay, a Boolean is something that only has two values, either true or false. We can also use yes and no or 1 and 0 instead of true and false. Booleans are used in programming for decision making, often deciding when certain functions and parts of programs should start or stop running. What are some other examples of Booleans in daily life? Well, if you flip a coin has heads or tails. So when you flip it, it only has one of two values, heads or tails. Okay, Boolean also has operators. Just like math operators, like plus, minus, times, and divide, and so on, Booleans have operators. The main Boolean operators are AND, where Boolean value A is true and Boolean value B is true, then both A and B must be true. The OR operator, if Boolean value A is true or Boolean value B is true, then either A or B can be true. And NOT. Boolean value A returns the opposite of A. Okay, we can use something called a truth table to see how this works. If we've got two values, A and B, if both are true, then A and B. The operator here is AND, so A and B is true when A and B are both true. A or B is also true. And not A is false when A is true. Okay, if A is true and B is false, then A and B is false. If A is true and B is false, then A or B is true. And not A is still false because A is still true. If A is false and B is true, then A and B is false. A or B is true and not A is true. And if A and B are both false, then A and B is false, and A or B is false, and not A is still true. Another way of doing a truth table is with zeros and ones, and this is probably the more conventional way of doing it. So here we've got A and B, and A could be 0, B 0, or A 0, B 1, or A 1, B 0, or both of them are 1. And again, if A and B are both 0, then A and B is 0. If A is 0, B is 1, A and B is 0. If A is 1, B is 0, A and B is 0. Only when A and B are both 1 that A and B is 1. Or if A and B are both 0, then A or B is 0. If A is 0 and B is 1, then A or B is 1. If A is 1 and B is 0, then A or B is 1. And if A is 1 and B is 1, then A or B is both 1. And not A again, when it's 0, not A is 1. When it's 1, not A is 0. There's a few other operators here. It's NAND, NOR, and exclusive OR. It just shows that there are some other operators. Okay, George Boole, he lived in the 1800s. He was an English mathematician, educator, philosopher, and logician. He worked in the fields of differential equations and algebraic logic, but is best known as the author of The Laws of Thought, which he published in 1854, which contains the rules of Boolean algebra. Okay, so we're going to look at a coin toss game. So let's create a table, a truth table, of possible outcomes when two coins are flipped. Then actually flip two coins and record the outcomes in your table. Now imagine a game where player A wins when the coins are the same, and player B wins when the coins are different. Write the pseudocode for each outcome using the Boolean operator AND, where heads equals true and tails equals false. Okay, so your pseudocode would look like this. Okay, so we've created a truth table. And so if coin A is heads and coin B is heads, then player A score is increased. if coin A is true, is heads, and coin B is tails, then player B score is increased. If coin A is tails and coin B is heads, then player B score is increased. And if coin A is tails and coin B is tails, then player A score is increased. Okay, and you'll notice that this is the exclusive OR function. It's only true when both are true or both are false. So player A's score is increased when both are true and both are false. Player B's score is increased when one is false and the other one is true. So what we learned, Booleans and Boolean operators. So now we're going to code a double coin flipper and then we'll look at a quiz. Okay, so lesson B is coding a double coin flipper. What we'll learn, we'll use Booleans to code a random double coin flipper, and then we'll review what we've learned. So, double coin flipper. You use your pseudocode from the previous lesson to code this game. You make the following variables. Boolean, we have a variable we'll call coin A heads, and is coin A heads true or false? Okay, so this variable will be set to true or false depending on whether coin A is heads. And we'll have another variable, coin B heads. Is coin B heads true or false? The number player A scores, okay, tracks player A wins. This is now, of course, a number variable. And a number variable, player B score, tracks player B wins. Okay, so when we start, we want to set coin A heads and coin B heads both to false, and player A score and player B score are set to 0. Okay, so we'll use an on-shake block to simulate the coin toss. Instead of setting coin A heads and coin B heads to false, use a pick random true or false block. Okay, so on shake, we want to set coin A heads to a random true or false, and set coin B heads to a random true or false. So it's going to, every time you shake it, coin A heads is going to be set to either true or false, we don't know which, and coin B heads will be set to either true or false, we don't know which. Okay, then we'll use a conditional if then else block to evaluate the outcome of the coin toss and increment the appropriate player's scores. Use a button to display the current player's scores. Okay, so we'll create a program that will do this. Your final program may look something similar to this, but we'll create it in make code. Okay, so let's open a browser and start coding. Creating a new project, we'll call it Unit 8, Booleans. Okay, so we want to start with our variables. Okay, so we'll start with the two Boolean variables, coin A heads and coin B heads. And then our two score keeping numbers, player A score player B score. Okay, when we start, we want to set coin A heads to okay, so on start, we want to set coin A heads to false. we set coin B heads to false. We set player A score to 0 and player B score to 0. And remember, in make code, when you set a variable to a value for the first time, it takes on the type of that value. So coin A heads is now a Boolean, coin B heads is a Boolean, player A scores is a number, and player B scores is a number. Okay, so now we said that on shake, what do we want to do? Okay, so on shake, we want to set coin A heads to a random true or false. So random is a math function, but instead of being a random number from 0 to 10, it's going to be a random true or false. Okay, and we'll do the same thing with B. We'll set coin B heads to a random true or false. Okay, so now we want to see who wins each round. Okay, now we want to check the logic. Okay, what was in our truth table? Let's just go back to that. Okay, if we look at the rules, we say we have a game where player A wins when the coins are the same, and player B wins when the coins are different. Okay, so we want to say if they are the same, player A heads equals player B heads, then player A wins, and if they're not the same, then player B wins. So we want to compare if coin A heads is equal to coin B heads, then we have to add 1 to player A's score. So we change player A's score by 1. Okay, otherwise, if they're different, then we change player B score by 1. Okay, so that's basically the logic. And then finally, we want to see what the scores are. We've done that many times before. We'll say when, let's say when button A and B are pressed together, then it should show the score. So it will show A, and then the value of player A score, and then it can pause, let's say for half a second, and then it should show B, and show the value of B score. And pause. And then we can clear the screen. Okay, so this is now the basic logic. I'm going to rearrange things so we can see everything. Okay, so when we start, coin A heads is set to false, coin B heads is set to false, player A score is set to 0, player B score is set to 0. On shake, coin A heads is set to either true or false, it's a random value, and coin B heads is set to true or false, a random value. Now we check if coin A is heads, if coin A heads is equal to coin B heads, so they're both false or they're both true, then player A score is increased by 1. Otherwise, if they're different, then player B score is increased by 1. And then if we press buttons A and B together, it will show letter A and player A score, pauses, then B score, and pauses, then it clears the screen. And we can try that now. Okay, so we shake. Okay, notice we haven't added any feedback. So I'm just going to shake a few times. That was 1 time, 2 times, 3 times, 4 times, 5 times. And now we press A and B together. A is 3, B is 2, so A won 3 times, B won 2 times. Okay, so that's basic game. We can add some feedback. So for example, on shake, we can show that some dice are being shaken. Okay, so we'll just show a picture. We'll pause. For half a second, and then we clear the screen. Okay, so this way you can see what happens. You shake, it will show that we've tossed the coins. Okay, so we'll just add some feedback. So on shake, okay, if player A score is increased, let's show the letter A. We already have it here, so we'll just copy this block and show it here. If we're changing player B score, we'll show a B. Okay, and so then we can pause for half a second, and we can show something to indicate that we're back to the main screen. Let's create a main screen. Instead of clearing the screen, we'll just have a nice little picture. Okay, and then this will get shown when we start. Okay, so on start, we'll show this logo. After shaking, and we've seen if it's A or B who gets the score, we then pause and then we go back to that same screen. And after we show the score, we can go back to that same screen. Okay, so now when we try it, when we start, we'll see our logo. We shake, A wins. We shake, B wins. Shake, A wins. Shake, B wins. A, B, 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 A, B, B, A. Okay, that's enough time. So now let's check the score. Click A and B together. A is 5, B is 3. And it goes back to the logo. Okay, that's our program. Okay, and don't forget, you should save early and save often. I'm saving this now that we're done. Okay, and we can go back home. Okay, time for a quiz. Okay, we had this code from our microbit alarm. So how would you describe this code with words as pseudocode? We've got on shake while not button A is pressed. Do play tone middle C for half a beat, then play tone high C for half a beat, and this is repeated while not button A is pressed. Okay, so if the microbit is shaken, as long as button A is pressed is false, the two-tone alarm will play. Okay, because normally if we didn't have the not, it would be while button A is pressed is true. But because we got not, the Boolean operator not means that this must be false for this to be true. Okay, how many values can a Boolean have? Of course, a Boolean data type has only two values, true or false, which we sometimes call 0 and 1, or yes and no. Name the three common Boolean operators we've discussed in this unit. Okay, we've got and, or, and not. But there are others that aren't all that common. What do conditionals like if-then do for Booleans? Conditionals like if-then check whether a condition is true. Why do we set the initial value of a variable inside the onStart block? The initial value of a variable is the value the variable will hold each time the program starts. Okay, and just remember that when you assign a value to a variable, it also takes on the type of that variable. So we saw that we had two Boolean variables and two number variables. We assigned them on start, so for the rest of the program, they are of that type. Okay, so what we learned, we used Booleans to code a random double coin flipper. And so you can do a Boolean project at home where you'll code a microbit program that uses Boolean variables and Boolean operators. You want to create a microbit program that uses more than two Boolean values. You're going to use Boolean variables, Boolean operators, and you can possibly use the random function. You remember when we did our mini project, we looked at all the different types of inputs. So we've got acceleration, which is a number, light level, which is a number, rotation, those are all numbers. So to use these, you would have an if condition where you say, is this greater than some value or less than some value, so that it becomes Boolean true or false. Button is pressed, that's always true or false. Compass heading, that's a number, so you have to say, is the compass heading between this and that? Then it means it's north. If it's between this and that, it's east, and so on. Temperature, that's a number, so you can have an if where you say, if temperature is more than 20 degrees, then it's hot, otherwise it's cold. Running time is a number, so you can say, if the running time is more than 30 seconds, then you need to do something. Okay, on shake, that's Boolean, true or false. On button pressed, Boolean, true or false. Logo down is Boolean, logo up is Boolean, pin pressed is Boolean, screen down and screen up. So on each of those cases, it's either true or false. So here are some other project ideas. We can have a sunscreen monitor. When you shake the microbit, it reports the current temperature in degrees centigrade. Button B measures the light, and if it is above 21 degrees and bright, it'll show a sun icon. If it is above 21 degrees and less bright, it will display a cloudy symbol. If it is dark, it will display a nighttime icon. And another idea, two-player game. Create a game in which two players take turns on the same microbit. Use Boolean variable called player A turn to keep track of whose turn it is. Use a Boolean variables and random values as part of a board game. Make a board, pieces, and a holder for the microbit, and try modding a current board game. Okay, so here somebody's created a board game using the microbit, and so you can come up with your own board game. Okay, so you use a design thinking approach and ensure the project meets these specifications. As more than two Boolean variables are implemented in a meaningful way, the microbit program uses Booleans in a way that is integral to the program, and the program compiles and runs as intended and includes meaningful comments in the code. Okay, so we've coded a microbit program using Boolean variables and Boolean operators. The next time we'll be looking at Unit 9, bits, bytes, and binary. That's all for today, so I'll see you next time.